And for that, we kind of introduced one of our solutions actually aims to solve some of the issues we know with TEs. And this is called Space Fabric. We just published it last week. And it generally tries to actually think of a future architecture for designing confidential computing in space. And it tries to address some of the challenges we see with TEs on Earth. And I will just provide some of the key contributions in here in high level and kind of how do we position ourselves. So in the past, there was also the direction about like just space TE, which was the idea of like having a software that is just available on your particular machine with physical isolation. But what we start to see more and more, and this will be definitely a big topic in the space industry, is like you want to not having a dedicated satellite for your particular mission, but you start to be interested in multi-tenancy. What does it mean? That you are not necessarily in the mood to trusting the other people that are sharing the same infrastructure. And for that, we are designing Space Fabric that is providing quite an interesting set of capabilities. Some of the unique issues that are known in the TE community is that, of course, I didn't dive into it in detail before, as a part of the TE attestation flow, usually the manufacturer itself is injecting itself into the hardware root of trust. TEs in general have the issue that they tell actually what is the code they are running, but they don't actually tell you anything about where is the code that is running. Of course, the other aspect is the auditability and supply chain. And lastly, especially I think with the announcement of Google, everyone is talking about it quite heavily, had to put it to the slides yesterday, is the post-quantum cryptography transition. It's possible, just like it's something that has to be, I think, more actively discussed as well. And looking at it, we try to look for possible solutions to these problems. So what we identify will be the suitable solution is make sure that the private keys that are used as a part of attestations are never generated on Earth. We are actually relying on two secure elements for our attestation flow. That one of them is open source completely, meaning actually even the hardware design and the firmware is open source. And the second one is established certified solution. And we have identified and designed our own instantiation of so-called proof of execution triangulation. In a short proof of ET, you can ask what came up first, if the ET or the actually word behind it. In this case, we are focusing on actually describing, which is the interesting property, is trying to find a way on how we can actually prove our execution is happening in space. And for that, we have instantiated our protocol that we call Satellite Execution Assurance Protocol. That actually is kind of using the ground stations to issue a form of like a challenge response protocol that will ensure that your satellite is actually really an authentic satellite and it's running in space. And we are in general providing and using the secure approach of making sure the host is secure. We are trying to minimize the TCP. We are finding the aspects of how to offload the sensitive compute to the TE in combination with the HSM that are providing us the key material, and in general try to provide attestations to its user. So we are unfolding all of these aspects in the paper, but the cool part from our side that satellites equipped with our solution will be available later on this year because we have 3 missions planned ahead of us, and the first one will be later this year in October. So if you're interested to find out more, you can check out the Space Fabric paper.